Welcome back everyone to Learning Mathematician. We're in statics and today we're gonna do problem 6.8. Okay, it says determine the force in each member of the truss and state if the members are in tension or compression. Okay, so what do we got in here? We got this member that is pinned at A and B. It's supporting these 900 and 600 horizontal forces, and we need to know what's the force that each member is applying. So as we did in the last video, we're going to apply the method of joints. So with the method of joints, the key part of this method is to find the joint that has the less unknowns. So in this case, if we take a look, joint E, for example, has force going to EA, force EC, force EV, force ED, so it has a lot of them. So we always have to look for the one that has less. In this case, as an example, is joint D. So as we can see, joint D only has ED, it has EC, and it has our 600 Newton force. So let's start with that one. So let's start with joint D. Okay, so what we do again is that we draw our joint D, and then we're going to draw the forces applied on this joint. So we got the 600 newtons going to our left. So like this, 600. Okay, what else do we have? We got the force ED, so like this, force ED. And my force DC, going straight down. Force DC. Okay? Now, why did I draw these guys? Again, going away from the joint because I'm assuming they are in tension. If my answer is negative, that means they're in compression, and that's how I like to do these problems. Okay? So let's start doing it by the summatory of forces in the x direction. What do we have in here? We got negative 600 minus the amount that FED is going. What is the amount? Well, if we pay close attention, this is a similar triangle also as in the last example, where this one is 8, this one is 6. That means that this is similar to our 4, 3, 5 triangle. It's really similar, okay? So what we got to do is that in our x direction, well, we got 3 out of 5. So we're gonna have 3 out of 5 of my force ED. Okay, if we solve for my force ED, what do we get? We get negative 600 multiplied by 5 over 3. And let's see how much this is. So we got 600 times 5 divided by 3. We get 1,000. We get negative 1,000. Okay? Okay. What does this negative tell us? Is that it's in compression, okay? But at the end, we will reinstate that. Next, we're going to do the summatory of forces in the y. And what do I have on the y? Well, I got negative F dc because it's going down, minus how much of this force ED is going down? It's going 4 out of 5. So we got 4 out of 5 of my force DE or ED, which is the same thing, and then this should be equal to 0. Okay, so if we solve for my force DC, we got force DC gotta be equal to negative 4 over 5 of FDE, which is negative 1,000. Okay, and then this should give me a positive 800 newtons. Why positive? Because this minus and this minus becomes positive. Therefore, my force DC is in tension. Okay, so we're done with that joint. So, which members do we know so far? We know ED, so we know this one and that one, and we know DC, so we know that one and that one. So the ones that we're missing are these other ones. So the next joint that I'm going to pick is joint C. Why am I picking that one? Because I know this force, I know the force DC, and all I'm missing is CE and CV. So I can solve for those members. So let's go for those. So I'm going to separate my work over here, and I'm gonna put my joint C. Okay, what do I have for my joint C? For my joint C, I got 900 newtons going to my left. I got my force DC, that if my joint D was going down, over here gotta go up in order to counter each other, so they're in equilibrium. Then I got my force CE going to the left, and then I have my force CV going down. Okay, we go again and solve for the summatory of forces in the X. What do I have? I got negative 900 newtons minus FCE equal to 0. I got nothing else, therefore my force CE, if we solve for that one, we get negative 900 newtons. And what that negative tells us is that it's in compression, okay? Now, summatory of forces in the y direction should be positive FDC minus FCV, and it should be equal to 0. Okay, we know our FDC, which is 800 newtons. We solve for FCV, therefore FCV will be equal to FDC, which is equal to 800 newtons. Positive meaning that is in touch. There you go. That joint seemed a little straightforward. Okay, the last one that we have is the last one I think is E. So we did this guy, we got CV as our value. We also got CE, so we know these guys too. All we're missing is AE and AB, and we should be done with that. So that's why I'm going to pick my joint E. So we'll go over here, I'm gonna draw over here joint E. What do I have? So I got my joint E over here. What forces do I have? Well, I got AE, so going like this. Then I got my force EV going this way. I got my force CE going to my right. Force CE. Now, why is this force CE going to my right? Because on my C joint, I draw it going to my left. Therefore, in order to be opposite and cancel each other out to our equilibrium, gotta be to the right. I got my force ED going up. Force ED going up. What else do we have? So we got this one, we got EA, EV, EC, and ED. So that's what we have. Remember, all these guys that are in diagonal are our similar triangle over here, our 5 4 3 triangle, okay? Then all of them are in the same way, like this. 4, 3 of 5 in this direction, same here. 3 in our x, 4 in our y, and 5 for our hypotenuse. Okay, so let's do this. We're gonna do the summatory of forces in the x direction. What do I have? Well, I got positive FCE. There you go. Then I got positive FED. How much of it? 3/5 of FED. Positive FEV, because it's going to my right. So 3/5 of FEV. And then I got negative 3/5 of FEA, and then that should be equal to 0. Okay? So just let's make a pause in here. And do we know the value of CE? Well, CE is this one over here, so we don't know the value. What about ED? So we know the value of ED, we don't know that value. There you go. Now, these two guys are the ones that are unknown for me. So what I'm going to do is that I'm going to solve for these two guys on one side. So I am going to have that 3 over 5. I'm going to do a common factor of these two guys of f e b minus f e a gotta be equal to, and then we're going to move these two guys over here to the other side of the equation. So we got negative f c e minus 3 over 5 of f e d. Okay? Now, if I just leave f e b minus f e a and I do the math, I need to multiply 5 over 3 multiplied by negative f c e minus 3 over 5 of f e d. And what is this equal to? We got the values for all these guys. So we'll have 5 over 3 multiplied by negative FCE. Where is FCE? It's negative 900. So negative and negative becomes positive 900 minus 3 over 5 of FED. What is FED? So my FED is negative 1000. So negative 1000. Okay? And if we solve for this, this gives us that the value of FEV minus FEA should be equal to 2500. Okay, so these are two unknowns. We need to solve for our summatory of forces in the y in order to get our second equation. So summatory of forces in the y should be equal to y. So what do I have? Well, I got positive FED. How much of it? 4 out of 5. So I got 4 out of 5 of FED. Then I got negative 4 out of 5 of FEV. So FEB. And then negative 4 out of 5 of FEA. And all this should be equal to 0. Okay? So what we can do is that since all of this is equal to 0, we can cancel out our 4 out of 5 from all of them. So I will have FED minus FEV minus FEA equal to 0. Which ones are our unknowns? So our unknowns are FEV and FEA. So these two guys. So I'm going to move them to the other side. Therefore, my FEV plus FEA gotta be equal to FED. And what is FED? FED is a negative 1000. So negative 1000 newtons. Okay? So we got two equations, two unknowns. All we gotta do is solve for them. So this is equation 1 and this is equation 2. Okay? So what I'm going to do is that I'm going to add them up. So I'm going to add this equation plus this equation in order to solve for 1. What do I mean by that? So if I write equation 1 under this one, you will realize that what I have is I'm going to erase this and put this negative 1000 really close. So negative 1000 newtons in here. And then if I write my first equation, FEV minus FEA should be equal to 2500 newtons. And then if I add these two equations up, what do I get? Well, I get FEV plus FEV. That gives me twice FEB, so 2FEB, and then FEA, minus FEA, because it's an addition, that gives me 0. So we got equal, and then minus 1,000 plus 2,050, that will give me, and 500, that will give me 1,500. And then if we solve for FEB, that should be equal to 750 newtons. We just need to divide this 1,500 by this number 2, okay? Now that we know EV, we can solve for E8 in any of these equations. So I'm going to do it on equation 2. So on this guy over here. You see? Now all I need to do is that my FEA is going to be equal to a negative 1,000 minus 750. Therefore, my FEA gonna be equal to negative 1,000 minus 750, and that will give me negative 1,750 newtons. Okay, so we found EV, so we found this member, and we found EA, this member over here. So we can write our answers as follows. So let's start with the first ones that we found. What did we get? We got FED, so FED equal to what? We found it equal to 1,000, negative 1,000. So 1,000 in compression newtons. Then FDC, we found it equal to 800 newtons positive, therefore in tension, what follows? FCE equal to negative 900, therefore 900 newtons in compression. Then FCV, which we found it equal to 800 newtons in tension. What comes next? FEV, which equals to 750 newtons positive, therefore in tension. And last one, FEA, we found it equal to negative 1,750, therefore 1,750 newtons in compression, because we found the negative. Okay, that was all for this video, guys. I hope it was helpful, and I'll see you guys in the next one.